Welcome to the Math Record. Today we'll be covering the CCML Geometry Contest 3 2016-2017 Division A. Okay, number 1. The diagonals of a quadrilateral bisect each other. What's the most descriptive name of this quadrilateral? Okay, this is basically something you just need to know, that if the diagonals of a quadrilateral bisect each other, they're going to be a parallelogram. It's just something you have to know. So, I don't know how you could prove this with math, but you could if you want, but if you just memorize it, you would know. Number 2, the measure of a regular heptagon. Find the measure of the interior angle of a regular heptagon, rounding your answer to the nearest tenth of a degree. Okay, the sum of the polygon with x side lengths is equal to 180 times x minus 2. Just think about it. If you have x is equal to 3, which is your triangle, is 180 degrees. If x is equal to 4, which is a square, it's going to be 360. So it makes sense. So each interior angle is that since you have x side lengths, that means you have x angles. So you just divide by x. So that will get your give you the answer. So a heptagon is x is equal to 7, so plug in 7. So 5 times 180 divided by 7. Convert that to a decimal is 128.6 degrees. Basically that simple. Okay. Question 3. A triangle with integer side lengths has a parameter 20. Given that one side length length 5, determine the maximum length of the longest side of the triangle. So let's say we have 3 side lengths, 5, x, and y, and x is the middle number and y is the largest number. So 5 plus x plus y is equal to 20. So x plus y has to be equal to 15. Determine the maximum side length. So basically, 5 plus x has to be greater than y because it has to be a triangle. And 5 and x is smaller than y. So the two small side lengths have to be greater than a larger side length. Yeah, 5 plus y is greater than, move the x to the other side, so you get 15 minus x. Add x to the other side, so that's 2x greater than 10. And x has to be greater than 5. So x has to be greater than 5. So the smallest integer greater than 5 is 6. So if x is 6, then y is 9. So the largest value for y is 9. That's the answer for question 3. Okay, question 4. One leg of a right triangle is 2 square root 3 and its hypotenuse is 3 square root 2. Find the length of the other side. So this is just a typical Pythagorean Theorem question. So leg 1, 2 square root 3 squared plus the other side length we'll say is x squared is equal to the hypotenuse, which is 3 square root 2 squared. So that's equal to 4, and that's 12, plus x squared is equal to 9 and 18. So x squared is equal to 6, so x is equal to square root 6. So that's your answer, square root 6. Okay, number 5, find x. AB is parallel to BD. Okay, I guess that was a typo because it's supposed to be AE is parallel to BD. This doesn't make sense because they're intersecting. So basically 12 divided by 5, because 12 is the longer one, divided by 5, which is the smaller one, because they're parallel. It's equal to x plus 6, which is the longer side length right here. X plus 6, all over the smaller side length, which is 6. And then cross multiply, you have 72 is equal to 5x plus 30. Subtract 30 would get you 42 is equal to 5x. So x is equal to 42 over 5. So that's your answer for number 5. Number 6. A rhombus has diagonals with lengths 9 and 12. What is the perimeter of a rhombus? A rhombus is basically just a quadrilateral with 4 congruent side lengths. So basically, when you make the diagonals, they're gonna be perpendicular to each other. So we're gonna have a 9. So that divides by each other. So it's 4.5 and 4.5, right? Because 4.5 plus 4.5 is equal to 9. And 12 divided by 2 is 6. So this is 6 and this is 6. So using your Pythagorean theorem, 4.5 squared plus 6 squared, and then square root that, you get the hypotenuse is 7.5. Since all these are the same side length, just multiply 7.5 times 4. And that's your perimeter, which is 30. Basically that simple. Question 7. Given the regular pentagon PENTA, find PENTA. Find the angle measure of AGT. Okay, something like this. Then here and here. So we need to find the angle of this first. So technically, let's as we said before, using for question um for question 2, we use that formula, which is 180, and then parentheses x minus 2 divided by x. So basically, using that idea, we have, instead of x is equal to 7, since it's not a heptagon, it's now a pentagon, use x is equal to 5. So x is equal to 5, so 180 times parentheses x minus 5 minus 2, which is 3, divided by 5. So each interior angle is 108 degrees. So basically, this is 108. Okay, so since this is a regular pentagon, you could think that angle T and angle E is basically the same. So right here and right here is the same. And angle G, we don't know what this is, but basically since it's a quadrilateral, right? Then basically it has to be add up to 360. So this one has to be something plus x plus 108 has to be equal to 360. So we could have 360 minus 108. And then that's 252 minus, sorry, 252 minus 2x. Sorry, it's really hard to write really small in here, so just please bear with it. Because like all these angles add up to 252 plus 108 gets 306, and the minus 2x plus the 2x plus the x here makes 360. So that's true. Okay, and since this angle also adds up to 108, that means this angle has to be 108 minus x. And uh and this angle right here is os is hmm since this is 108 minus x, this is also 108 minus x because this two side lengths are the same, so it's isosceles. So that's also 108 minus x. So based on that, um since these two are the same technically, then this is also 108 minus x, right? And since these two lines make a vertical angle, then technically this angle right here is 252 minus 2x. So since this is also a triangle, then technically it's going to add up to 180. So we have these angles which you add it up. So 108 plus 108 plus 252. So 108 plus 108 plus 252 equals 468. And negative x, and negative 2x, next negative 4x. And all this has to add up to 180. So 468 minus 180 divided by 4 is 72. So x is equal to 72. Since we're gonna now look at this line basically, because we want to find this, because that's the angle we want to find, AGT. Since now we just plug in x is equal to 72 into here. So 252 minus 2 times 72 gets you 108. Since that is 108, 180 minus 108 is 72. So the answer to number 7 is 72. There probably is another way to prove this without doing all the math, but if you want to do this, then it makes sense. Because I'm guessing what the proof is that you prove that angle N and angle G is the same. So if that's the same, then you could find out this angle because you already know this is 108, so this will be 72. Pretty interesting question though. Question 8. The ratio of the number of diagonals to the number of certain sides of a certain polygon is 50 to 1. What's the interior angle of the sum? What's the interior angle sum of the polygon? So let's say you have diagonal, side length x, right? So x is right here, is in that ratio. And our diagonals was, remember the formula, 180 x minus 2 divided by, sorry, it's not the angles, it's the diagonals. Okay, the diagonal formula is basically just x, the number of side length, which is x, times x minus 3 divided by 2. So that's the formula. And that goes by 50 to 1. So write that. So x minus 3 divided by 2. Let's move x over here, so that gets x divided by 2. Since that ratio, because what you will be writing is that it's 2 over the entire ratio is equal to 50 over 1, basically. So you just put the x right here, ready? So it's equal to 50 over 1, which is just 50. So the x cancels out. So x minus 3 divided by 2 is equal to 50. So x minus 3 is equal to 100, and x is equal to 197. So that's 897, right? Oh, no, it's looking for the interior sum. So the interior sum is basically, let's move this up. Because we know the side length is now 197. Oh, sorry, it's not 197, it's 103. 103. Sorry, can't subtract, can't add. So the sum, as I said before, was 180 x minus 2. So plugging that into your calculator, you have 180 times 103 minus 2 is 101. You get 18180. So 18,180 degrees as the sum. So that's your answer. Okay, number 9. Given that AS is perpendicular to AE, okay, and RE is perpendicular to AE, find AE. So they given that RS over here is equal to 20. Since since a triangle AVS is similar to RVE, because you could prove it, because let's say you have something like here, right? So you have something like this. This is 90 and this is 90. Vertical angles have to be the same, so if this is x, this is x. So these two angles, let's say, are y, basically. They have to be the same, you know? Because this is x and this is 90, and they're both the same on each side. So they have to be the same. So basically, this is 9, and this is 6. Let's call this x, and we'll call this 20 minus x, because this entire length is 20. That tells us that x divided by 6 over here is basically equal to 20 minus x. 20 divided by 9, because it's similar. So cross multiplying. Okay, let's move the thing up. Cross multiplying, we have 9x is equal to 120 minus 6x. Add 6x to the other side, so 15x is equal to 120. And 120 divided by 15 is equal to 8. So x is equal to 8. So AE, we need to find AE, basically. So based on our diagram, what do we have? We have 9 here, we have 6 here, and we have 8 here, because that's what we have for 8. So this one's 12. So using the Pythagorean Theorem, this is a right triangle. We have 12 squared minus 9 squared square root will get us the side length right here. So that's 12 squared minus 9 squared. That's square root 63. So square root 63 is just 3 square root 7. And now we have now we need to find this side length also, because you gotta find AE. So this only gets AV. So now we need VE. So that's 8 squared minus 6 squared. So 8 squared minus 6 squared, square root 28, which is going to be 2 square root 7. So adding them together, you get an answer of 5 square root 7. Okay. This basically just lets you like solve as similar triangles and then using Pythagorean theorem. Not really that difficult. Just know your formulas and concepts. The altitude of an isosceles triangle with base square root 12. Find the altitude of an isosceles triangle with base square root 12 and leg 2. Okay? So we have an isosceles triangle with base square root 2 and length 2. So the legs are 2, so this is 2, and this is 2, and the base is square root 12. Okay? So we need to find this height. So divide square root 12 by 2. So it's only this side. So we could ignore all this, basically. So now we just use the Pythagorean theorem. So 12 square root 12 divided by 2 squared is equal to 12 over 4 plus, let's call this x. X squared is equal to 2 squared, which is 4. So 12 divided by 4 is 3. So 4 minus 3 is 1. So x squared is equal to 1. So x is equal to 1. So that altitude is equal to 1 for 10. Okay. Number 11. Given the diagram below as marked, give the inequality of y, where angle M is acute. Okay. So angle M has to be less than 90 degrees. That's what it tells us. So since this is a quadrilateral, right? Then since this is a right angle, 90 plus 123 plus angle M has to be and plus we'll just, since this is a straight line, this angle has to be equal to 180 minus y, right? Because 180 minus y plus y is 180. So they all had to add up to equal to 360, basically. So using a calculator, 360 minus 90 minus 123 and minus 80, minus 180, and minus y is equal to minus negative y is equal to y plus 33. Oh wait, sorry. Y minus 33 is equal to m. So plugging that in, so y minus 33 has to be less than 90 degrees. And sorry. And since this acute angle has to be between 0 and 90, so it has to be 0. And you add 33 to both sides, so it's equal to, so y is between 33 degrees and 127 degrees. Make sure you don't forget it's between two numbers, because it cannot be negative if you think about it. Okay, so that's the answer. It's between 33 and 123. Okay, number 12. The angles, three vertices of a parallelogram have coordinates 2, 5, 10, -3, and 13, 4. Find all possible coordinates of the remaining vertex of the parallelogram. So let's kind of draw the picture. So we have 2, 5 right here ish, and then 10, -3, and then we have 13, 4. So you don't have to be the most precise about it. So technically, we have these 3 points. So what you kind of do is that you kind of draw basically kind of like lines. So imagine, since you have a parallelogram, right? So let's say you have 4 points of a parallelogram. What you do is that you draw a line and then you draw the line of the other side. And you kind of connect those points and you kind of make those diagonals. So if you think about it, right? We have these 3 points. We draw a line here. Then basically we have a point right here if we draw a line. So there's a point right here, possible here. There's if there's a diagonal right here, right? Basically, then there's a point right. Then there's a point right here. And if you have a point right here, that means we have another point right here, basically. So that's what we're going to be looking for this general idea of how this parallelogram works. So we just need to draw it. So if this was the first line, well, basically So that's the general idea. So let's say the first one is this, right? Let's mix this diagonal. Then we just need to. This is 2, 5, and this one is 13. Sorry. Let's actually start from this point and go. Actually, never mind. 2, 5, and this is 10, -3. And the point that corresponds to 10, -3 would technically be this bottom point, which they already gave us, which is 13, 4. So what you need to do is that you gotta -8, and you gotta add a -8 and -8 on the x and add 8 to the y. So your -8 is 5, and add 8 to the y, which is 12. So the first coordinate is 5, 12. Okay. Erase this. Oh wait, actually. So the first answer is 5, 12. 5, 12. So our next one would be like sorry, I need to erase this one also. Oops. At this point. Okay. So we already got that point there. So imagine we made a parallelogram like down here. Then basically you're gonna have the same point. So imagine there was a line here. That line is either gonna go up here or it's either gonna go down here. So basically oops, sorry, I did that wrong. So we have 3 points right here. Basically, let's make a line, and say this is x. Then basically it's the same idea, where this line is parallel to this line, and this is x and this is x. So either the point is here, or it's down here, which is the other side of the x. Let me take away the x. We're gonna use x to say where the point is. We have a point here, or we're gonna have a point here. Or if we made a line right here, basically we're going to have the same point right here, or if the point is right here. So these are the original points right here. Okay. And now if we connect this point, then basically another line would be basically if it goes right here and the point right here. So technically there's only 3 possible points where they can intersect. Right here, here, and here. Because all these lines are basically the same thing. Now we just need to find it. So if we have let's say 2 points, so it's 2, 5, and 10, -3. -3. Okay. Then 2, 5, and 10, -3. Then the corresponding points, if we have 13, 4 right here on the top, right here, then basically it has to go down to this point. So you gotta +8 and then -8. So +8 is 21 and -8 is -4. So your first one is 28 minus 4. I mean 21 minus 4. Okay. And that's the first one, which gets this point right here. Now let's get this point, which we already got, but I'll just show it again, which is if this is if the bottom part, which corresponds is basically this way to this way, then this one is 13, 4. So you got a -8 on this side, so that gets 5. And you got to add 8 on this one, so it's 5, 12. So the next one is 5, 12. And now the third one. So let's cross all this. Okay. So basically, we're now going to use these 2 points. So it's 13, 4 and 10, -3. So which one corresponds with the 13 point, which is this point right here, which is already given, which is 2, 5. And now we just need to look for the bottom part because you have to go down. You also have to go down, right? So this one has to have, you have to -3. So -3 is -1. And this one is -7. So this one -7 is -2. So the last one is -1, -2. So those are our 3 points: 21, -4, 5, 12, and -1, -2. Yeah, sorry, that looks a little bad. -1, -2. Okay, and that's basically how you find it. You just kind of draw a diagram and you get the idea of how the shape looks. 13. In a certain convex polygon, 2017 different diagonals can be drawn. Find the minimum number of um, sides the polygon can have. So basically, um, let's say we have a side length is x, right? The number of diagonals was given the formula x times x minus 3 divided by 2. So that equals to 2017. So multiply by x minus 3. Let's just factor that out, which gets x squared minus 3x. That's get 2017 times 2 is 40, 34. So you minus 40, 34 equal to 0. Um, basically, let's just kind of factor this out using our calculator. The one has to be minus and one has to be plus. So what does 2017 factor out to? Which is nothing. Wait, what? Oh, wait. Sorry. Calculator is not working as intended. So we have 2017 different diagonals. In a certain convex polygon. 2017 different diagonals can be drawn. Find the minimum amount of size the polygon can have. So we have x divided by x times x minus 3 divided by 2 is equal to 2017. So, sorry, you can't factor this out because 2017 doesn't work. So basically, let's say I have negative b using quadratic formula, negative b plus or minus b squared, 9 minus 4ac. So 4a is 1, c is negative 4036. So you just add 4 times 034 over 2a. So 4 times 4034 is that number plus 9 square rooted. It's not gonna be negative because like you can't have negative side lengths. So add 3 and then divide by 2, which is like, so that gets this x is equal to that. So x is sorry. So x is, so getting from your calculator you get something about like 65.031488, etc. basically. So really repeating decimals. I mean, not repeating decimals, like infinite decimals. So since it's 65, that means um it has to be greater than 65. That's what's telling us, because it has at least 2017 different diagonals can be drawn, different diagonals. So since it's 65, you can't go less than it because then you have less than 2017. So you gotta have 66, which is just one more than the six. I mean, not one more, but like it's the integer greater than the 65.0 something. So your answer is just 66. Okay. Number 14. There are 680 ways to select 3 numbers from a set of positive even integers less than or equal to 34. If such a selection is made, find the probability that the number will form a Pythagorean triple. Write your number as a reduced fraction. Select three numbers from a set of equations less than or equal to even integers less than or equal to 34. If such a selection is made, find the probability that the number, the probability the numbers will form a Pythagorean triple. So positive even numbers. So I'm guessing they're talking about like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 8, 30, 32, 34, basically. So how much numbers is that? That's 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, there's 17. So just to make sure that 680 is since select three numbers from the set. So it will be 17 factorial over 3 factorial all over 14 factorial. So that is equal to 17 factorial divided by 14 factorial divided by 3 factorial. Yeah, 680. That's equal to 680. So these are our numbers. So what's the find the probability that the numbers will form a Pythagorean triple. So basically looking at our numbers, if you kind of just know your Pythagorean triples, which is just like 3, 4, and 5, and the next one after 3, 4, 5 is 5, 12, 13. 13, and then it's 7, 24, 25. Then it's 8, 15, 17, and um, basically I think that's it. Kind of. So with 3, 4, and 5, since you want to make them all even because that's all you could choose from. Just multiply this one by 2, so that gets 6, 8, and 10. So that's one way. Or you could have multiplied by 4, which is 12, 16, and 20. So that's another way. So that's 2. Multiplied by 6, which gets to 18, 24, 30. So that's another way. You can't go with 8 because that makes 40. So you're gonna have to stop at 30 when 5 is 30. So there's only 3 ways for this one. 5, 12, 13, you can multiply by 2, and that's all. And you can't multiply by 4 because then 13 times 4 is 52. Same 7, 24, 25, you can't multiply by 2. 8, 15, 17, you can multiply this by 2 to get 34. So this is 1, this one's 0. So how many find the probability that the numbers that you can make it. So 3, choose. Actually, don't do this way. It's actually not going to be helpful. You actually gonna have to we might be missing some. So you might just want to test them, I guess. Because let's say we have you can kind of just go on your calculator and make a spreadsheet. So what you kind of do is that let's say let's make this x. Right. X is the number that you're gonna put in, which is your hypotenuse. So you have square root and then variable x squared minus our next value, we'll call that y. That y. Sorry, I'm using an n spire, so it might be a little bit easier for me. And you gotta just make sure that it's the right one. So you put 34, 2, 2 doesn't work, 4 doesn't work, 6, 8, 10, 12, 14, 16. So 34, 16, and 30 works, which is just what we used for our sorry, for a for a triangle. Actually, I think our thing works 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. There was 1 here, there was 3 here, I think, and 1 here, and 0 here. So that's 4. Oh, I'm trying to check. Divided by. Oh no, that I'm adding it wrong. 3 plus 1, 3, 4, 5. So that's 5 out of the 680 ways, right? Because each triangle counts 1. So 6, 8, 10. Was it this one, which is 12, 16, 20, and then 18, 24, 30. Then we have 10, 24, 26, and 16, 30, and 34. So 5 out of the 680. So 5 divided by 680, or just have 680 divided by 5, and that gets the denominator, which is equal to 1 over 136. So that's your answer, basically. Okay. Number 15, in the diagram below, AB is equal to 28, and CD is, where's CD? CD is equal to 64, and BD is equal to 64. I mean, sorry, CD is equal to 64, and BD is equal to 46. And AB is parallel to CD, and M is the midpoint of AD, and N is the midpoint of BC. So let's kind of draw this out. And we have the midpoints. So this is equal to this one, and this one's equal to this one. Okay. And we draw the diagonals. Ooh, sorry. This is such what a strange diagram. So let's move it a little lower. We have to have that space in between. Okay. So they said that AB is 28. And they said what is this? CD is 64. And BD is 46. So this thing is 46. Since this one is the midpoint of these two, then technically, if you think about it, this triangle. Wait, is it? Um. Find EF. So. Let me think about this actually. Then I guess we're gonna have this triangle since let's think about just this by itself, right? So we're gonna think about this triangle and we're gonna think about this triangle because we have 28 and 64, right? And we have BD is 46, so we call this X and we call this 46 minus X because they had to add up to 46. Then technically you could just use similar triangles. So X divided by 28 has to be equal to 46 minus X divided by 64. And cross multiplying, you get 64X equal to 28 times 46 minus 28X. So add the 28, so 64 plus 28, which is 92. So 28 times 46 divided by 92 is equal to 14. So getting this out. So we can substitute that back in. So X is equal to 14. Sorry. This is 14. And this one is 46 minus, was it? 46 minus 14, which is 32. So this side length is half of basically this one. I mean, since this triangle's lengths are half of this length, which makes, what is it? Wait, no, it's not. But the side length, the corresponding side lengths to here was 28 to 14 and 64 to 32. So it's just half. And now, basically, we just need to look at this other. Now we just need to find EF. So how do we do this? So we know. Okay. So we know this is equal to this. So basically, we're just gonna use this triangle now. Basically. So we know that this. So we need to find this side length. So basically, for that, we know this is half. So if this is 28, right, then this has to be 14 because they're similar triangles, right? Because they share this angle and these two side lengths are extended out. So we know, based on that, we know this this entire side length is 32, but this one's 14. So MF is 14 and DE is 32. So knowing that, we know this one is the same thing. So we know this entire side length has to be, since this is 64 and we're looking at this triangle, right? Then basically it's gonna get a 64 divided by 2 because it's similar again. So this one's 32. So this one's 32 and this is so basically that's just 46. So basically this is just half of that angle. So now we're just gonna have to look at I'm just getting as much information as I can because I want to see how this works. So if this is 32, that's 14. So that's 14. That's 46. What? So that's 14-ish. Now, oh, sorry. Okay. So this is 14, right? So, and we use, that gets from this triangle. So we know that's 14, but using this triangle also, 28 here, and since these are the same angle, then 28 here, this is also 14, basically. So since this is 14, and we're using this triangle right here already for another similar triangle, we know that this is 14, and half of this, basically this entire thing is 32. So 32 minus 14 is 18, so you know this one's 18. So based on that, we know we're just gonna use this triangle now. So we know this one is 32 because that's what we got first. So 32 out of 64, right? Because that's the bigger triangle. Divide by this smaller triangle, basically. Let's use a different color so you know what I'm looking at. So this triangle right here, actually, that's such a terrible color. Use red. Right here, this triangle right here. So now we're using that one. So 32 divided by 64 is equal to, let's say this is x, right? The new x over, this one's 18 over 18. So this one is basically just a half. 32 over 64 is half is equal to x over 18. So x has to be equal to 9. So the value of number for number 15, EF, which is the value of this x right here, is basically 9. So you basically just have to look for similar triangles. So the first thing you do is that you use triangle ABE and triangle CDE, and then you basically separate line. You're given that line BD is 46, so you separate it into DE and EF. I mean EB, so you get those side lengths of those two lengths, and from there use triangle ABD and triangle BC. I mean BFD to get similar. Since they're similar triangles, that means AB, which is 28, means that since this is halfway through, then MF has to be 14. The same thing for GN, which is also 14 because it's similar for ABC, and GNC. So that's 14, that's 14. And then use DBC and triangle DBC and triangle FBN. So you know those are half angles. So this one, I mean, half similar triangles. So this one's 6, and DB is, DC, which is CD, 64. So FN has to be 32. But since you already know that GN is 14, so 32 minus 14 is 18. So FG is 18, and you basically just use EDC and EFG and use similar triangles to solve for EF. Okay, so this is basically just a bunch of similar triangles. So just a lot of work there. Question 16. Three numbers are selected one at a time with replacement from the set 1, square root 2, square root 3, and 2. Find the probability that the triple chosen would be side length of a cube or a triangle. Since they say with replacement, what I usually do is that I kind of make like a system. So my system for this one would be like if there is one of the side lengths are the same, none of the side lengths are the same, two of the side lengths are the same, and three of the side lengths are the same. So basically, let's think about it from like 3, 2 to 1. Because 3 would be like if all three side lengths are the same, so they're equilateral. Since any equilateral is possible, that means say 3, 2, and 1. That means basically all of them will work. So we could have 1, 1, 1, square root 2, square root 2, square root 2, square root 3, square root 3, square root 3, and 2, 2, 2. So all those work. So those all are equilateral triangles. So there's 4 possibilities because there are 4 of them. And now we have the two of the side lengths are the same. So now we just need to check if they work. So if we have 1, 1 and square root 2, does that work? That's 1, 1, that's square root 2. Nope, that does not work. Because 1, 1 square root 2, it's basically a right triangle. So that doesn't work. Can we have 1, 1 square root 3? That's 2. And that is less than, right? Yeah. Actually, can you have 1, 1 square root 2? 1, 1, and square root 2. Nope, that doesn't work because that's right triangle. 1, 1 square root 3. That is 2. And 3 is greater than 2. So since 3 is greater than 2, that tells us that because it's supposed to be a squared. Sorry. A squared plus b squared has to be greater than c squared. So the two smallest side lengths squared, adding them together has to be greater than the last length for it to become a choose. So basically, since 1 plus 1 squared plus 1 squared is 2, which is less than square root 3 squared, which is 3, then basically it's going to be obtuse, so it doesn't work. So if square root 3 is greater than 1 squared plus 1 squared, then 2 squared is obviously greater than 1 squared plus 1 squared. So none of the 1 squared works. Now square root 2, and 1. That works because basically if you kind of think about it, kind of have a side length. So you have square root 2, square root 2, and if this is 1, right, then you guys subtract, and that's 1/2. And 1/2 is obviously smaller than square root 2, so that has to work. So square root 2, and 1 works. Now we have square root 2, and now this one is square root 3 over 2. Square root 3 is about um like let's just see if that works as a right triangle. Let's see. So 2 squared plus 2 squared is 4, and 4 is obviously greater than square root 3 squared, which is just 3. So it's gonna be acute. So that works. So 2 of them already works. Square root 2 and 2. That's a right triangle because square root 2 squared plus square root 2 squared square root that is 4 is 2. So that doesn't work. So only 2 of those work for square root 2. 0 work for 1. Square root 3. 1 and square root 3 is greater than square root 3, so anything with those works. So square root 3, and 1 works. Square root 3, and 2. That also works because 3 because 3 plus 2 is 5 is greater than 3, so that works. And square root 3 and square root 3 and 2. That also works because square root 3 is like higher than 1, so it's like this: square root 3, square root 3, And this entire thing is 2, so halfway is just 1, basically. And square root 3 is greater than 1, so it's going to work. So 3 of square root 3 works. Basically all 3. Now 2. 2, 2, and 1. That works. 2, 2, and square root 2. That works. And 2, 2 square root 3 works. And 2, 2. Yeah, so all 3 of these work. So that's 6, and that's 8. Okay. So if you think about it, you have, let's say, 1, 1, and actually not 1, 1. We're gonna have 2, 2, and square root 2, right? You can either get 2, 2 square root 2, or 2 square root 2, 2, or square root 2, 2, and then 2, right? So there's 3 different ways to put it, because you could just move the digits to the exact place. So each of the 8 possibilities have 3 more ways. So just multiply by 3, you get 24. Okay. And now, number 1, there's only 4 combinations because it's just 1 square root 2 square root 3. This is 4 choose 3. So it's just 4 factorial over 3 factorial over 1 factorial, which is just 4. So you have 1 square root 2 square root 3, 1 square root 2, 2, 1 square root 3, 2, and square root 2 square root 3, and 2. This is a right triangle, so this doesn't work. 1 square root 2 and 2, that's 1. That's 3. And 3, 2 squared is 4. So this is going to be obtuse, so this doesn't work. 1, 3, and 4, that's right triangle, so that doesn't work. And 2, 3, and 2, that gets 5 over is greater than 4. So yes, this works. So this is the only one that works. Since you could get this in square root 2, square root 3, 2, 2 square root 3, square root 3, square root 2, 2, and square root 3, 2 square root 2, or 2 square root 2 and square root 3, or 2 square root 3 and 2. Those are the 6 possibilities, because you choose 3 and then 2 and then 1. So it's just 3 factorial for all of them. Even though it's 1, you could choose it 6 different ways, so you have 6 of them. So adding that all together, 4 plus 24 plus 6, that's 34 out of the total amount. So you could choose, since they could replace it, that means since there's 4 of them, it's just 4 to the power of 3. Because you just choose the one number, right? So how many numbers can you choose from here? You could choose 4 for your first number. Now since you choose the first number, now you could choose the second number. So what numbers can you choose? Since you replaced it, you could choose all 4 again. And vice versa for the third. So now it's just 4 times 4 times 4. So it's just 4 to the cube. So 4 to the cube is 64. So 34 divided by 64 is equal to, let me just write that here again, I'm running out of room. 17 out of 32. So that's your answer, 17 out of 32. So that would be your answer for question, what is this question? Question 16. Okay. Question 18. In diagram below, GOEN is a square with side length 1, and rectangle GLDN and is similar to LDEO. Find OL. Okay? So you kind of just like make some kind of ratio. So you think about it, you have a square. It might not look the best, but it's just 1, 1, 1, 1. And let's call this X. This X and this also 1. Okay, so they're saying G L. So we just have GL, so that's 1 plus X all over GL DN. So let's have L and N. So GL is the top portion and LD is the bottom portion, which is just 1. It's equal to LD, which is a 1, over DE. So DE is X. So that's what they're telling us. So we just need to find OL. So OL is equal to X, so we just need to find X, basically. So just make an equation using your triangle. Given the information above, you get x squared plus x is equal to 1. So you have x squared plus x minus 1 is equal to 0. So using the quadratic formula, negative b, you can't have minus, because if it's negative b plus or minus b squared over 2ac, you can't have minus, the minus version. Because if it's a negative minus a negative minus another number, there's just gotta be another negative. And you can have a negative side length, so it has to be plus. So negative 1 plus b squared, which is 1, minus 4ac, minus 4. A is 1, c is negative 1, so that's just plus 4 all over 2a. So x will equal to negative 1 plus square root 5 over 2. So that's your answer. Negative 1 plus square root 5 over 2. Number 19. Find the area of a triangle with side measures 5 squared, 5 squared plus 6 squared square root, 3 squared plus 12 squared square root, and square root 8 squared plus 18 square root. So you want to know if that's a if that's a right triangle, because it might be. So we have 5 squared plus 6 squared, because if you square a square root, it's basically just the original number. And you have 3 squared plus 12 squared, and you have 8 squared plus 18 squared. So using your calculator, you have 5 squared plus 36, 25 plus 36, which is equals 61. 3 squared plus 12 squared, which is 153. You have 8 squared plus 18 squared, which is 388. So 61 plus 153 is obviously smaller than 388, so it's not going to be a right triangle. So basically what that tells us is that since 61 plus 153 is less than 388, it's going to be a obtuse, so something like this, right? So that's basically what we have. So we have these 3 side lengths, so we have 5 squared plus 6 squared. Let's just write it again, because now we just know it's obtuse. Because the first thing you ever want to do is that if you see a triangle with 3 side lengths, you might just want to check if it's a right triangle, because then you could use the simple base times height formula. So now you have this, so you have square root 5 squared plus 6 squared. Squared plus 6 squared. And you have 3 squared plus 12 squared. And you have 18 squared plus 8 squared plus 18 squared. What you should do is that you should use the Heron formula. Since it's a calculator contest, you just gotta plug everything in your calculator. You're not gonna do any of this portion by hand. So because the Heron formula is really strange. It's either Heron or Heroes. I don't know. It's same thing. So basically, let's just find the 3 side lengths. So it's like 5 squared plus 6 squared, and yes, 3 squared plus 12 squared. So find all those numbers in decimals. Basically, don't round. Just keep it in your calculator. 8 squared. Okay. So basically, with those numbers, add all those 3 numbers together, and then divide by 2. Okay. So you have that number, and have that number subtracted from the first number, from 5 squared plus 16 squared square root, and then have that number again subtracted by the second number, and then have that number subtracted by the third number. Okay. So you have these, and then basically have that number that multiplied by the by all those remaining of those 3 numbers. So you multiply all those together, and then you square root it, and you should have an answer come out as 21. Basically, so the formula for Heron is get this out. So the Heron formula is basically the area of a triangle given side lengths A, B, C, right? Its side lengths are A, B, and C. It's basically its perimeter divided by 2 let's just call it the semi-perimeter. We have S. S is its semi-perimeter, so S is equal to its perimeter divided by 2. So the area is equal to S, and S minus the first side length, S minus the second side length, and S minus the third side length, basically. So basically that's what you're gonna do. So you calculate the perimeter and then divide by 2, and then you have the perimeter subtracted by all 3 of those numbers, and then you multiply them all together times the semi-perimeter. Don't forget you're gonna be multiplying 4 numbers, and then you square root it and you gotta find the area. Since you have a calculator, you're gonna come out with like really ugly decimals, but then at the very end, your calculator will be able to like actually get a really good integer. So it's gonna be 21. If you're using a graphing calculator. I'm not sure about a normal one though. Okay. And number 20. Oh yeah, so 19 would be answer 21. Number 20. If AD is equal to 2 and BD, okay, let's actually just draw this out first. So we have something like this, and we have this. Okay, if AD is equal to 2 and BD is equal to 4, calculate DE. So we want to find this length right here, basically. And they say AC, AC is perpendicular to BC, so this is a right triangle. And CD is perpendicular to AB. Okay, so this is perpendicular to each other. So and AE bisects CAD. So these two are the same angles right here. A pretty cool formula about the basically of a of this kind of if there's a right triangle in a right triangle, so let's say you have a right triangle, right? And then you make a height in there is a really cool property. So basically what it states is what it has is that, let's say call this A, right? A squared is equal to this entire side length, we'll call it C, times that smaller one right next to it, right? So basically A squared would be equal to 2, the smaller version right next to it, times the entire thing, which is 6. So that's 12. So A squared is equal to 12. So A is equal to 2 square root 3. And the same thing applies here. So let's call this B. So B squared is equal to 4, the one right next to it, times the entire side length, which is 24. So that would be equal to 2 squared 6. So you could check if this is true, because you could just have 2 squared 3 squared plus 2 squared 6 squared. So that's 4 and that's 12, and that's 4 and that's 24. That equals to 36, and square root 36 is 6, which is just 2 plus 4, which is 6. So that works out. It's a pretty cool property. And and now we're gonna use now using these side lengths, we're gonna find DE, so this side length right here. There is a pretty cool theorem which is called the angle bisector theorem, which states that something like this. So let's have A and B, right? Then this is X and X, so they're the same angle, and this is C and D. Basically, it states that if these are bisected, A divided by B is equal to C divided by D. That's what it states. So now we just need to find the side length of the height. So we just need to find so that's 2 squared, so it's a right triangle. 2 squared plus, let's say the thing is X. Let's say Y, the height. No, let's call it H. H squared, the height, is equal to 2 squared 3, which is 4, and then that's 12. So H squared, 12 minus 4 is 8. So H is equal to 2 squared 3. 8 is 2 squared 2. Sorry about that. So this entire side length is 2 squared 2. Let's just call this A, and we're gonna call this 2 square root 2 minus A. So that adds up to 2 square root 2. That's the height. So using the angle bisector theorem, so basically 2 divided by 2 square root 3 is equal to A divided by 2 square root 2 minus a. And now, let's move it up. And now we just need to solve this basically equation. I mean, yeah. So cross multiply, so you have 4 square root 2 minus 2a is equal to 2 square root 3a. Now you just multiply, add 2a to the other side, so you have 4 square root 2 is equal to 2 square root 2, 2 square root 3 plus 2a. And then you have 4 square root 2 divided by 2 square root 3 plus 2, which is equal to a. And the answer set rounds to the nearest hundredths. So using a calculator, 4 times square root 2 and 2 square root 3 plus 2, and then basically divide those numbers. And you should have an answer that comes out to 1.035276, etc. So you round up 1.04. So that's your answer, 1.04, rounded to the nearest hundreds. But this is the most precise answer. So if you write this down, you're gonna get it wrong, but technically you're not wrong. So that basically covers everything for the CCML Geometry Contest 3 2016-2017 Division A. Thanks for watching, and I'll see you at the next math record.